Assalamu alaikum. My name is WAJAHAT Karim, and today we have a topic of Lab 9 of TLD. In Lab 9, we have adders and subtractors, and we have five exercises, five examples, and one exercise. So, first, we will move on to our first example, and we have a code here. So, we want to call test. There, we have written code earlier. There is x and y, and we have to get the sum of x and y. So, first, we will simulate it. As our simulation is successful, so we will move on to our RTL viewer. Locate in RTL viewer. There we get our result. So now we'll move on to our universal VWF simulation. And at first we will get our nodes, insert our nodes, and there we have x and y, and we will get some later after the simulation. So we will arrange this, and we will get the input value here. I'm just putting a random number. And we will change this to unsigned decimals, so we can check our results. Now I will simulate it, and there you go. We have 10 plus 22, and we got 32 as our sum. So now we will move on to our example number 2. Now we have example number 2. In example number 2, we have to write the Verilog code for an 8-bit unsigned adder with carry in. So we will move on to our quarters file. In our quarters file, we have a following code. X and Y are input. C1 is showing, Ci is showing carry in, and we have a sum here. So we will move on to simulation, and first we will get our RTL viewer because I simulated it earlier. Without wasting time, this is our RTL viewer. Now we will move on to university VWF file. We will insert the nodes here. There we have our two inputs, so we rearrange them, and so we will put here any random values as we have done earlier, and here you go. And and we will keep the C1 0 and we will get the sum here. So we will change the sum also to unsigned decimal and we'll simulate it now. There we go. We have our simulation. We have 24 plus 3 is equal to 27, and we have carry in. So now we will move on to our question example number 3. In example number 3, we have tried a Verilog code and an 8-bit unsigned adder with carry out. So we will move on to our quarters file and we have written code here and simulated earlier. So we will get our RTL viewer. Here you go, this is our RTL viewer, and now we will move on to VWX University file and we will insert our nodes here. After getting our node, this is our X and Y. So we'll put here values of X and Y. Just put any random values and we change them to unsigned decimals. We get our show to 0 carry out, and now we'll simulate it. Yes. Here you go, we have our result 2 plus 8 is equal to 10 with carry out. Now we'll move on to our example number 4 here. In example number 4, we have a same Verilog code and unshaded with adder, but this time we have both carry in and carry out in the same code. So we'll move on to here quarters file where we have X and Y our variables and sum hai, we have sum by carry in carry out and this is our sum code. So as we have simulated earlier, so we'll first move on to our RTL viewer. There you go, this is our RTL view, and then we will move on to our university WF file for further simulations. Locate our node here, node finder list, and these are our code inputs. This is our sum, this is our carry in, this is our carry out. We'll take both 0 and we'll get some in unsigned decimal and we will input some our values here and we will turn them into unsigned decimals so we can get a clear answer. And now we'll simulate it. There you go, this is our 25. 9 plus 16 is equal to 25 with carry in carry out. So this is our example number 4 is completed. Now we'll move on to our example number 5. Example number 5, we were asked to write a code about 8-bit unsigned data subtractor with carry in, carry out, and use select input S to select between addition or subtraction. So we'll move on to our quarters file here. Here we have x and y as inputs, we have results, and we will have select here. So as we use select, it will if we have 1 in select, it will give us a minus with subtraction, and if we have select is equal to 0, we will get some x plus y. So we'll move on to our RTL viewer. This is our RTL view, and now we will move on to our university VWF file and locate our nodes here. There we have x and y inputs. There we will get results, carry in, carry out, and this is our most important function, select. So first we will get adder by keeping it equal to 0, and we will input our value here. Just put any random value, and here, and we'll convert them to our unsigned decimal so we can check our answer instantly. And select is equal to 0, and this will be get equal to 0 too, and I will simulate it. Yes, there you go. We have 12 plus 20 is equal to 32. Now we will move on to subtractor. So we'll put select is equal to 1, and we will run the same simulation again. There you go. We have 20 minus 12 is equal to 8. So this is our subtractor. Now we'll move on to our exercise number 6. Here in exercise, we were asked to construct a 4-bit ALU logic unit, and ALU should contain at least 10 of this following. It means we have to get any of the 10 and write the code, and we have to state the function that was used in Verilog. So we will comment that in our code. So we will move on to our code here. So this is our Lebanon exercise code. We have ALU inputs, ALU selection, and we have 8-bit output, and we have carry out. And we have get multiplication, addition, division, logic shift left, rotate right, logical and, logical or, logical nor, logical XNOR, greater comparison, and we have wrote some other codes, but we have deleted, so we will get these 10, and these are our inputs: 1 2 0 1 2 3 4 5 until 9. So we have simulated earlier, so without wasting time, we will get our altair viewer. There we have our RTL view. This is our RTL view. So we will on to our university VWF file for further simulations. We locate, insert our nodes here. This is our S and T are our inputs, and this is our ALU selection. This is our carry out. So we will first get inputs, like putting any random number in these 8 bits of S and then of T. And as we have done earlier, we will change them to unsigned decimal so we can judge our result quickly. This is our carry out, and we will put our carry out is equal to 0, and ALU cell we will use clock here, and we will put the period of 100 nanosecond to get our results. This is our, so now we'll simulate it to get our ALU output. There you go. Yes. There we have 27 plus 5, and we got our ALU outputs, all of them here, and we have carry out 0, and our simulation is successful, and our lab is completed, and because we have 6 simulations, we have done all 6. So thank you for watching, and Allah Hafiz.